Welcome to Module 2 of our Explainer series. I'll be your Senior Identity Architect today, and man, am I excited to dive into this with you all. This session is built specifically for those of you in the trenches, the network admins and system engineers keeping our environment secure and operational every single day. Today, we're getting past the surface level stuff and looking at the advanced engineering precision it takes to truly secure your Active Directory domain services. We're going to tear down the walls and examine the deep architectural blueprints that make the whole thing tick. So here is our roadmap for today. 1. Introduction. Then we'll move to 2. Hierarchy. After that is 3. Domain controllers. Then we hit 4. Technical handshake, focusing on Kerberos and DNS. Next is 5. GPO law. And we'll wrap it all up with 6. Outro. All right, let's jump right into section 1, building the logical directory. At the absolute foundation of this hierarchy, we have the schema. You can really think of the schema as the actual DNA of your network environment. It's a strict, rock-solid set of rules that dictates every class of object and attribute inside your directory. It sets the exact constraints, the limits, and the naming formats for every single identity, computer account, and shared resource you've got. You know as well as I do, you can't build a secure house on a shaky foundation, right? Architecturally speaking, the schema is where the whole shebang starts. Now, to actually make all that highly structured data useful and universally accessible, we bring in the global catalog. This is what maps out all our structural objects, things like servers, volumes, printers, and user accounts. It essentially holds information on literally every single object in the directory. And this is a massive deal architecturally. It enables your authorized users and admins to find directory info seamlessly, completely regardless of which specific domain actually holds the data. It is, for all intents and purposes, your ultimate enterprise index. Moving right along to section 2, domain controllers, the infrastructure pillars. So how do we keep these pillars perfectly aligned? Well, we rely on a highly efficient ADDS replication service. This service distributes your directory data all across the network. Every single domain controller in a domain participates in this. That means each one maintains a complete, totally synced copy of the directory data for its domain. If a user updates a password or an admin changes an attribute, boom, that change immediately replicates out to all the other domain controllers. It's exactly what gives your enterprise architecture that massive high availability and fault tolerance. But here is the million-dollar question. How do we securely authenticate against these distributed controllers? We really have to contrast the older, highly vulnerable NTLM protocol with the modern standard, which is Kerberos. NTLM, or NT LAN Manager, is a legacy challenge response setup where the target machine just stores password hashes. Frankly, NTLM systems can be cracked in a matter of hours these days. It just can't protect sensitive data anymore. Enter Kerberos. Microsoft brought this in way back in Windows 2000, and it's a huge upgrade. It uses strong symmetric key cryptography and, crucially, relies on a trusted third-party authentication system to verify who's who. Which brings us nicely to Section 3, Technical Handshake, Kerberos, and DNS. Specifically, the Kerberos Cryptographic Exchange. Let's start with a fun fact from our sources before we map this out. Kerberos is actually named after Cerberus, the mythical three-headed dog that guarded the underworld. And since this protocol requires exactly 3 entities to authenticate, it kinda hits the nail on the head. Let's look at phases 1 and 2. The client explicitly requests a ticket-granting ticket, a TGT, from the Key Distribution Center, or KDC. The KDC then verifies the user's credentials. If everything looks good, it securely fires back an encrypted TGT and a session key. That TGT is actually encrypted using the ticket granting service's secret key, and your client just quietly stores it locally. It's this incredibly secure, totally invisible process for the end user. Now let's see what happens in phases 3 and 4 when that user actually tries to access a resource, like a file server. The client takes that stored TGT, bundles it up with the target resource's service principal name, the SPN, and sends it over to the ticket granting service, the TGS. The TGS verifies the ticket and basically says, yep, this user has the right to be here. Then it sends a valid session key specifically for that service right back to the client. Finally, the client hands that session key over to the target resource to prove its access rights. And boom, access is granted. It's a totally elegant, highly secure cryptographic dance. Okay, transitioning to Section 5, GPO law, structuring architectural constraints. To quote our source documentation directly, policy-based administration eases the management of even the most complex network, and that is the absolute truth.
Relying on group policy objects, or GPOs, is essentially the governing law of your environment. It's what allows us, as system engineers, to securely manage these vast, sprawling deployments without having to pull our hair out manually configuring thousands of individual endpoints.
A really prime example of this is using DNS group policy settings. This lets us dictate exactly how network traffic, AD search technologies, and identity requests are routed securely across the environment. By enforcing these routing and security baselines right at the domain level, we're guaranteeing that all those complex Kerberos handshakes and domain controller replications we just talked about are happening over trusted, tightly monitored pathways. And finally, that brings us to Section 6, Outro, Threat Models and Attack Vectors. We absolutely have to architect defenses against some really severe threat vectors. Attackers out there use pass-the-ticket methods, literally forging a session key to present to a resource without ever properly authenticating. And that often spirals into a golden ticket attack, which, terrifyingly, grants complete domain admin access. Or a silver ticket, which gets them forged access to a specific service. Even scarier, the DC shadow attack. That's where attackers get enough internal access to just spin up their very own rogue domain controller, injecting malicious changes right into that replication service. These identity-based attacks are specifically designed to bypass your KDC entirely. So, as we wrap up this explainer, I want to leave you with a critical architectural challenge to really chew on. Just how resilient is your network's Kerberos implementation against a silent, identity-based intrusion? Is your enterprise architecture actively monitoring for privilege escalations, brute force attempts, and anomalous Kerberos tickets that are just bypassing your domain controllers completely? Remember, security isn't just about building a strong structure. It's about continuously watching the gates. Thanks for hanging out with me for this explainer, and I seriously encourage you to take this blueprint and review your own AD environments today.